percent. Percent, I like to say, is a way to do decimals for people who already hate math. What would happen is, if you look at a percent problem, someone says 25% of the students from Norwalk are going to buy their books online. Okay, at least I don't like numbers, but 25 I can do that. If they want to do that as a decimal, they would have to say 0.25, and if you start with a decimal point, you're going to lose more people that way. And of course, you can use the fraction, but not a lot of people like fractions. Percent seems to be the case of the math option of relating two numbers as to their relative sizes that is hated by the fewest people. So percent wants to look like an integer more frequently than the decimal values that we have going on. So percent means over 100, because per means over or of, cent means 100, so percent means over 100. That's one of the three things that we need to know about percents to have a good running start on how to do this. Number two, there is a way to align percents into a proportion. And that would be that you want to take the percent, which if they tell you what the percent is, it is the number that must go over 100, because percent means over 100, equals is over of, or it can mean new over standard. We look at how much something is made up of the old or of the standard value, right? We can even say new over old, but that can get a little bit weird, so I like to say new over standard, but new over old isn't really horrible either. And the third thing we need to know is that Sean's rule is done this way. It's a way to solve proportions. And this goes back to someone I taught when I was early in my teaching career, teaching high school in Cheshire. And Sean was a rough kid. Seemed like a decent sort, but he may still be in Cheshire, because he wasn't hanging out with the right individuals. Anyone know what's in Cheshire? Probably not down here in Norwalk, but there's a Connecticut State Prison in Cheshire. But I'm not saying he's there, but Sean was a rough kid, and you wouldn't expect anything helpful to come from him because he was kind of tough and all that, but he had something that he knew really well. He shared it with me. It works all the time. I always give him credit for it. And here's what Sean's rule is to solve proportion, to solve a proportion. Now, proportion is two equal fractions. And if you remember me saying don't call something cross-canceling, if you're doing canceling, call it canceling, and it doesn't always have to be at an angle, right? And that's because people mix it up with the concept of cross-multiplying, which is when you multiply what they used to call the means and the extremes in a proportion, but you would multiply the 100 by the is number and the percent by the of number, and those two would be equal. So I used to teach that a lot. Or I would teach clear the fractions, and let's see what we can get. And I'll still show you that, because that's a strong way to keep learning how to deal with the solving equations and clearing fractions. But Sean's rule to solve a proportion is two parts. It is multiply the diagonal numbers and then B, divide by the third number. Now, what do I mean by a proportion? I mean you have two equal fractions, and three of the spots, there's a top and bottom, numerator and denominator to each fraction. And three of those will be numbers. Either two tops are numbers and one of the bottoms, or two bottoms and one of the tops are numbers, and then there's an unknown variable, and that's it. You can't have like x plus 5 over there. You're going to have to clear the fractions, or maybe cross multiply to do that. But his way for these percent problems is awesome. He could do it so fast. I mean, he could do it as fast as I could because he knew how to do it on his calculator. So I want to show you how those work when we get to the problems that we're dealing with. And I have to advise all my students every semester. I say, if you say, oh, percents, I'm great at this, I can take the day off, I'll just do the homework and it'll be awesome. In fact, why don't I skip this lecture? I don't think so. There are harder problems than just, what is 20% of 45? Okay, let's be real. But you want to be able to find it when the percent is missing, when the is missing, when the of is missing, and this method will work for all of them. And having that ready is going to let us do things like when I say, the camera is now $78 and it's 13% off what was the original price. And you're kind of stuck on that one if you're sort of doing the old introductory method of percents. So we've built in strength into the method that this uses to allow you to do the more difficult problems. So you're going to want to master the content of the stronger problems. So we're going to sneak up on you and have you handle the tougher problems. All right. Here's the first problem. What is 30% of 70? And if you're like, oh, I know how to do these, and if you already know the answer, which I know, that doesn't mean you know how to do all of them. Okay. 84 is what percent of 50? I don't. Maybe you got some other, like you memorized 3 ways or 2 ways and one you can't do. It's not a good way to go about it. And then we have this one. 306 is 90% of what? Now, some people think I'm a nice guy, and at times I am. But because so many of us think this is the only thing we need to do with percents, and I know how to do that, so I'm not going to learn anything new in percents, bet on this if you're a betting person. I'm not going to ask you this kind. I'm going to ask you this one maybe, or this one, or maybe those two, because I want to make sure you can do the kind that's not just like, hey, turn it into a decimal, multiply them, and you're done, especially, if I get access to a calculator. But what I want you to do is circle from the ends. So I'm not going to circle based on which is the word what, or which is the is, which is the of, but I do need to relate something is the percent, something links with is, something links with of. What does 30 go with here? I'll fix my is, I just can't like the way that is looks. 30 is squeezed between is and percent. So is that 30% or does 30 go with is? Okay. Am I doing is what or what percent? Am I doing is 90 or 90%? Got a way to show you. What we do is we circle from the ends. They're not really circles, okay? They are ovals, but here's what we do. We look for is, of, or percent, and we begin at the start of the question, what is, and then we stop when we hit the is. And then we go to the back, and we back our way in toward this. We go with the 70, and we circle back until we come up with of. See how this one goes. 84, there's is, I'll loop back. Of 50. 50 back to of. Okay, now we got this one. I want to rephrase that one on the bottom. I want to say 90% of what is 306. Here's why. 90%, I'll grab the percent. And I'll take the 306, I'll go back and grab it. My claim is the bottom two are asking the same question. But what we're going to do is we're going to set up, percent always goes over 100, so I kind of have this set up for us where we have something over 100 equals something over something. So we got 3 blanks. But the 100 is always 100 because percent always goes over 100. And I find it easiest for people to understand, let's get that percent done right away. Right, let's have it parked, ready to be catching our percent. Now, what happens here is if I see the word what, I'm not going to use X. I'm going to use W for what, or N for number, but I'm going to use W for what, but you can use X if you want. What is? Percent over 100 equals is, that's where my W goes, over of. Next thing I see not circled at all is 30%. So I'm going to put my 30 over here because 30%, 30 over 100 equals W over of. And I'm going to come back and I'm going to say of 70, 30% equals W over 70. You're not memorizing where each one was for what each one does because that's not going to work so great for you. What I'm going to do here is 84 is, I left out the blanks. Eighty-four is green. Percent over 100 equals is. Here's my 84. What percent? That means I got a W for percent. So I don't know what I'm doing with percent. So I'm going to put my W for percent. W over 100 equals 84 over of. And of is going to be 50. Now come over to this one that I just wrote shortly ago. 90%. 90 goes over the 100 because it's percent. 90 over 100 equals is over of. I don't know the of. So 90%, 90 over 100 equals is over W. And the is 306. Yes, it's the last spot remaining, but it also is where the is number goes. We all have roles to play in solving this problem. 306 is. Percent over 100 equals is. There's my 306. 90%. Percent over 100 equals 306 over of. And of what? I don't know. So now I'm claiming the two on the bottom are the same. We're going to take Sean's rule and we're going to work on what he said. We're going to see if that rule can make some sense to you. And the reason for that is, if you can work with Sean's rule and set up your proportion correctly, then you can successfully finish these problems, right? Because you're going to divide by the right thing. When I taught the class and not everyone had their calculator, I could ask the following question. What number do you divide by? And if you gave me the right number to divide by, I'm hoping you could multiply the other two and divide by that number and get me the exact answer. So looking at the setup, you can ask what number you would divide by. Now the number you're going to divide by is diagonal from W, or whatever letter you put in for your variable. So the letter I'm going to divide by here, go diagonally through the equals. This is a divide by 100. Put my W on up here. This is a divide by 50. This is a divide by 90. This is a divide by 90. I don't have to memorize it. I just have to do it. So now, let's find out what W is supposed to equal. And I'm going to show you up here in algebra how it works out that way. So let's see what we got. This says multiply the two diagonal numbers 30 times 70, I don't care which is first or second, and divide by the 100. You can take your calculator, no matter what the numbers want to turn out to be, as far as how they're going to mix with each other, and go 30 times 70, or 70 times 30. You don't even have to hit equals, but then divide by 100. This gets me 21. And that's telling me that 21 is 30% of 70, and some people go like, okay, or yeah, I totally see it. What we're looking at here is 30%. That means the new number is small. If you're over 100%, the new number, the number you're making that is new, is going to be big compared to the old number. We have 30%, 70 is big, and the new number is small when I got 21. Now let's go to this one. W and 50 are diagonal from each other. Therefore, W equals 84 times 100, or 100 times 84 over 50. Give you 168. Now we should take a look at that. The percentage came out to 168. That's what I found, but let me see if they fit together right. The percentage is 168. The new number should be big. When I'm over 100%, the new number should be big. The new 84 is big compared to the old 50. That's done correctly. If you do it upside down, when you're supposed to get big, you'll get small, or when you're supposed to get small, you'll get big. So we do use that to check our numbers out. Here we're supposed to divide by 90, right? W is diagonal from 90. So W equals, I got 306 times 100, so I'm going to go ahead and do 306 times 100. I'm going to divide by 90. 340. I just found the old number, the standard, to be 340. This is 90%. That means that the new number that is made should be smaller than the standard. 306 is smaller than the 340 that I just found to be the standard. Try the last one. I'll sit over here, we won't go near it for a little while, and I'll let you look at it and I'll ask you what you divide by, in case you're a student who doesn't have your calculator today. And you need to divide by 90. Doing that correctly means the other two, the diagonal numbers, the 306, which is diagonal through the equal sign, from 100, are going to get multiplied together. It doesn't matter which one is first. So I'm going to go with the 100 times 306, and divide by 90. It does matter what you divide by. 340. Now we just found the old standard of number. Now 90% means the new number is smaller than the standard. 306 is smaller than the 340 I just found. It doesn't matter which one you find. If you have a percent bigger than 100, you're creating what is a larger number than the old one. If you're creating with a number where the percent is below 100, you're creating a new number that is smaller than the old standard. And that's how those work. But I want to show you how this works when I have my algebra to deal with. 30 over 100 equals W over 70. What I want to do is I want to get rid of all the denominators. And so I want a number that's large enough to cancel this 100 and the 70. So what I need is 700. Okay? If I jump by hundreds, it won't work till I get to 700. If I do 700 over 1 and 700 over 1 times each side, this will become 7. This will become 10W. 10 there. 7 times 30 is 210 equals W times 10, and we'll divide by 10. W equals 21. And I had to wonder, was Sean just lucky or does he have something here? And it turns out that whatever you're diagonal from when you cross multiply is going to create what you're going to divide by if you don't reduce any of the fractions. And that's the same effect that we would have when we go through this multiplying by the LCD and getting them to drop out of being fractions, and then work out the deals with integers, and then we may still come back to a fraction when we're all done. But if I have this one, W over 100 equals 84 over 50. The number that works is actually 100. 100 is the bigger of the two, and it does divide by 50. So if I come through and do what you're supposed to do, multiply each side by 100 over 1. It's one fraction equals another, so I can multiply in front of the one that has space on the left and behind the one that has space on the right, and it's fine. Because now when I divide by 100, I get 1, divide by 100, I get 1. So here I'm looking at W equals, divide by 50 and I get 1, divide 100 by 50, I get 2, and I multiply those two, I get 84 times 2, which is 168. And that's what we're supposed to do algebraically. We're supposed to multiply by the LCD so that we don't have that around anymore. So now if you'll notice, this is 90 over 100 equals 306 over W. Either one of them, even though the words were put at you in different orders. By starting on the ends, you make sure that the 90 has to go with percent here, and the 306 has to go with is, and of gets what's left over. The what? 306 has to go with is here, because it's got no other choice. Of has to go with what, and that's how you get them lined up. So I'm going to take this one down and show you how the arithmetic that we did with Sean's rule would work out if we did it with algebra. So I've got that one over there, I got 90 over 100 equals 306 over W. 90 over 100 equals 306 over W. This is a little bit weird to some people, but it's great because we can even get a W to cancel. I need to cancel 100 and I need to cancel W, so let's multiply each side by 100 W over 1. 100 W over 1. We'll divide 100 by 100 for 1 and 100 by 100 for 1. We'll get 1 times W times 90 equals, and we'll cancel this W down to 1 and that W down to 1. 306 times 100. This is 90W equals 306 double O. Divide by 90. If we look at 306 double O, 30,600, divide by 90, we have 340. What this has given us is an opportunity for me to have you set up proportions to solve equations involving percent. So Sean's rule is perfectly legal in my mind, and so is clearing the fractions of the proportion. But percent definitely means over 100. Percent over 100 will always equal is over of, or nu over standard. In some of the problems we'll see that come up. And we can use Sean's rule or clear fractions and then solve for our missing value. So that's no problem. And that gets us a good start. That tells me how, it doesn't matter if I'm missing the is, the of, or the percent portion of the proportion. It doesn't matter which one's missing, because I can divide by the number that's diagonal from it. Cross multiplying is similar, does the same job as clearing the fractions out. But we've learned clearing the fractions out as a tool that we can use in all aspects of this, so then cross multiplying doesn't become this extra thing we have to learn, but we do have to solve for the missing part of the proportion. Now, I want to get to this concept of simple interest. It's not the way all interest works anymore. I teach math for liberal arts, and we learn about compound interest as well. And that's more useful in the world for a lot of things. But simple interest is going to be P times R times T, where P is your principal. It's the amount of money that you try to borrow. R is your annual rate, but it'll be the rate of a percent in most cases, and percents have to go over 100. So if you see 7%, throw that 7 over 100. Somebody say, isn't that 0.07? In fact, it is. But 0.07 is a different format of 7 over 100. And sticking with the concept of percent is that number over 100, it'll get to be 0.07 and do the job of 0.07 as needed. And T equals the amount of time, which is really the number of periods. So some people call it PRN. But you want to do your principal times your rate times your time. How many periods is what the time will come. But we'll get through what we have to do in this. Now, what you owe is a little bit tougher in some of these problems, because you don't just pay back the interest. You don't borrow $1,000. Maybe you owe $70 in interest. You don't just pay them the $70 and say, thanks for loaning me the money, here's your $70 and I'm gone. You have to pay back the money you borrowed as well. So the interest is the extra money you pay. I explain interest deeply in Math for Liberal Arts, but here's the story. You're basically bribing them, not in a bad or illegal way, but you're giving them money for their interest in helping you. You're buying their interest. They're not saying, here, take the $1,000, give it back to me whenever you want. No. You're saying, because you're taking enough interest to give me your money for a little while, I'm going to pay you for it. That's called paying interest. Okay. So all percents start at 100. And 100%, here we go, 100% over 100 equals 1 over 1, and that's 1, and that's what's going on. 100% means you've got a whole one. If you've got 100% of something, you've got exactly a whole one, no extra, and we're not short at all, 100%. So we begin with 100 and either increase or decrease when we begin with percents of change. Rent went up 17%. Or I'll just say rent increased rather than say, went up. What's the new percent? Start at 100, increase with plus 17. You can go 117%. So if rent went up by 17%, it is now 117%. It's the old rent of 100% plus the 17 extra percent that made it higher. The number of car buyers decreased by 20%. New percent, start at 100. Right, you've heard it, keep it 100, but we're not going to keep it 100. We've heard that phrase, keep it perfectly solid, representing what is 100%. But now this is not going to be keeping it at 100. This is going to drop 20% off, and that's going to be 80%. And all percents begin at 100 and then they move from there. They can go higher or they can go lower. The most you can drop a percent by is 100% and have it all be gone. But there is no limit to how high you can go. Percents can go above 100% for growth. There's no limit to how much something can grow, but how much can it shrink once it becomes zero? It ceases to exist. So I want to do a problem with here. We'll leave that up, there's room for it. And it says, this year, 4,800 people bought cars. That was a decrease of 20% from last year. It's the kind of question I might ask you on the exam, for example. How many people bought cars last year? So we see a decrease, and we see that this mentions that there was a decrease of 20%. So we go 100 minus 20, and we get 80%. Here we go. That's going to lead me to 80 over 100. And now we have to deal with what is the standard and what has been changed. Right? What's it changed into? 4,800 people is this year. And 4,800 is the people that changed to become 4,800. That's the new number. It's not the standard number that we had. So therefore, the 4,800 is going to go on top, where we say the new number, maybe that's what you think of it as, but the changed number is definitely this 4,800. And then here we got last year. Now let's go figure out, using Sean's rule or multiplying by 100L on both sides, what that gets for us. How many cars were bought last year? How many people bought cars last year? All right, I'm dividing by 80. 4,800 times 100. I'm going to divide by that 80. 6,000. People bought cars last year compared to 4,800 this year, because we lost 20% of that 6,000, but we didn't know the 6,000. We knew we had 4,800. So by setting it up as a percentage over 100, here's the smaller number from this year and the larger number for last year as percents. Here's the smaller number for this year that we know and the missing number from last year. We were able to find the number that we started with, which you can't do the other way. You can't go, oh, give me 80% of 4,800. Let's say we tried that way. We say, I got 80 divided by 100 times 4,800. Got 3,840. All right. So now what does that do? 3,840, who's that? You didn't have 3,840 last year. You had 6,000 last year that dropped down. So by going with the percent over 100 equals is over, percent over 100 equals the new over the standard, it's going to get us to where we need to be. Therefore, we were able to find an old number, which would be the missing value and really tough for a lot of people to come up with. So you might think that we'll go with 120% of this, right? That, you figure, oh yeah, let's go 20% more. That's not going to work either. If you say, well, let me get 120% of the 4,800. 120, right? If I got 120 here, 48, it's not going to work for you. You get the wrong number. This is going to go up in orange. You think, if we dropped by 20 from last year, we must have gone up by 20 for this year. This is wrong. Because 6,000 is the number that's going to get us there. But let's see what we go. 120 times 4,800 divided by 100. 5760. talking about 20% dropped off the L that we don't know, not 20% dropped off the 4,800 or 20% got added to the 4,800. We don't want 20% of 4,800. We want 20% of a number that's bigger than that. And that's why this is incorrect. So you can't say, oh, we can go do that. You kind of need to have a setup where you have old and new related to percent. And all we know is that we have an 80% to go with 4,800, and then don't know the other one that it came from. So tipping. I've had members of my family working in restaurants for a while, so I always mention this. Tips should actually be spelled all in capitals, because it stands not for like, hey, let me give you a little tip off the dollars that I have, or let me give you some information or some money that you can go buy in. It's not that. It stands for to ensure prompt service. And by giving the tips in the US, we think when I come back to this restaurant, they'll treat me well because they know I gave a nice tip, and I want to reward their good work, and I want them to be a good server next time when I come back. Okay. In Europe, they do it differently. In Europe, they pay a living wage to their wait staff, and it's a profession that people can live on, and they don't have to basically suck up to the people that they're waiting on in order to get paid. And so some Americans will come to the idea that then they're not going to get any good service because the waiters get paid the same all the time. It's not a problem in Europe. Some people come from Europe and they don't understand the tipping culture, and they won't leave a tip because they think that the waiters are making living wage here without waiters and waitresses without getting tipped. So tips are a very big thing in the U.S. They've tried tipping restaurants in New York where they had no tipping. They said our prices are a little higher, but don't tip. Our waiters are paid with living wage. We're like, you were so great. Let me give you a tip anyway. So it's really hard to break the habit. But tips are based on a percentage of the total bill. And let's say that we come up with this. If you want to tip 20%, on a bill of $40. So $40 is what the bill comes to. It's got the tax and all that. And if you want, you can just pay the $40 and take off. But the way that it works in restaurants where tipping is encouraged, which is service restaurants, you should probably leave some kind of tip. And here's my opportunity to quickly tell you that if you get bad service, you're not supposed to give them a bad tip and think that's going to make it better. There could be lots of reasons that someone had a bad service moment, and what you're actually supposed to do, as bad as it sounds to a lot of people, is if you get bad service, you're supposed to alert the manager. You're not supposed to storm up to the manager and say, I insist that this person be fired because my water came to me warm, or something like that. No, that's terrible. But you just let them know that you didn't have a good experience with this person. And there may be a lot going on that makes sense as to why it happened on that one day. Or that server may be terrible. And the restaurant doesn't want you not giving them a tip and then leaving, and the restaurant manager doesn't know that the wait staff is terrible, and then you tell your friends, don't go there, the waiters are terrible, and then nobody goes to the restaurant. The manager wants to know if there's a problem, to make it right, and to try and fix it for you, and to try and fix it for the person that's working there. So you shouldn't use tips as a weapon to get back at someone whose service you weren't thrilled with. You're supposed to tip. It's your choice. It is voluntary, but Americans, service industry people, do need that to make a living wage. It's just the way it is. So for that reason, I want you to be knowing how to tip and how to do this on that. If you want to tip 20% on a bill of $40, what we should do is say, I'm going to put 20% onto the 100% of my tip. Tips are higher now, actually, if we're still, as we are now in the fall of 2020 in the pandemic, because restaurants are getting smaller crowds and therefore fewer people to serve and therefore fewer bills, people might be tipping a little bit more to try and keep the wait staff in the restaurants going. That's a different situation. That might change the 20%. How you do it once you get the number in there is still the same. So we got to go 120% over 100, which would be my old bill. And this would be my new bill, and what I was supposed to pay back then was 40. So now we'll go like n equals. And we'll see what happens is in this case we're going to divide by 100, so we'll go with 40 times 120 and put it over 100, and that'll get us 48. And you leave $48 and the tip is in there. Another way to do it is to say, now let's go for 20% of the 100 equals my tip over $40 bill. Okay, so now my tip is equal to, we're dividing by the 100. So we're going to go 20 times 40 over 100. That equals 800 over 100, and that gets you 8, and you tip $8. But then you got to leave the 8 as well as the 40 and $48. Okay. Tipping is traditionally based on a percentage. It used to be 15%, and in the cities it might be 20, where people, I don't know, there's just reasons tipping culture's been different. I've heard it's gone up to 20%, but maybe I'm talking to a lot of waiters and waitresses, but these people do tend to work hard. Two big things I want you to know is how to find the percent, because I'm your math teacher, and to let you know that if you have a bad service experience, actually the right move is to alert the manager of your experience. They may give you a free meal, they may give you a free dessert, they may not do anything. They may explain to you why it's wrong, they may apologize, they may not, but the right move in most cases is to do that and not to wield your tipping as a weapon. The other thing I want you to know is that if you do work in the service industry where tipping is the way people make the money, they do depend on that, and so they should be doing a fair job for you so that they earn it and earn the right to keep working there. But tipping is just sort of part of the cost of going out to eat. And sometimes people are just not aware of that. They're like, well, too bad they became a waiter, they should have done something else. Okay, you can be like that, but think about what you're saying if you now know that that's the way the system works. So that's how we can get the tip going in there. Now, I want to do another one. Suppose our bill is $35. Let's tip 25%. How much should we leave? $25%. We take the 100 and we add 25%. 125. So we got 125 is the new percent over the old 100%. And here's what we're going to leave, so I'll call that L. And down here we have this $35 bill. Now we're going to have a calculator to get through this. We're going to divide by the 100 here. L equals 125 times 35 over 100. And I see $43.75. $40 on 35, so it would be $43.75. Maybe round it up to 44, whatever. Another thing you should know about tipping culture is if you're paying with cash and they come back and they say, I'll be right back with your change. If you were able to leave them the $43.75, or if you even decided for whatever reason to push up to $44 or $45 and you're giving them the exact change, you'll hear people saying it's all set, which means your tip is in there and you don't owe me anymore. And that's just another part of the tipping culture. But tipping is something where we need to know our percents, or we need to have our calculator. People used to walk around with little cards that told them how much was which percent of what number and try to hit it that way in order to get the tipping right. Or, as you might well guess, the whole time since I've been about 10 years old till now, which is a lot of years, if I go out with a mixed group of people, they would frequently hand me the check and say, figure out the tip. Or worse yet, they'd be like, figure out what everybody owes when everybody got different stuff. And then there's other stuff going on as well, right? Sometimes you go out there and somebody will order 2-3 drinks at $10 each, and then they'll order a steak, and here you have a salad and a burger. Your bill is like $15, and their bill looks like it's going to be around $45. And what do you think they might say? Why don't we just split it up evenly? You got to decide what to do about that. But there's actually an interesting thing that happens, and it's called the surf and turf effect, which is if you know you're all going to split the bill evenly, then you're going to order an expensive meal because they're going to order an expensive meal, and you don't want to pay $30 for something that should cost you 10, 12, whatever it's going to be. So that's going on too. But there's all this going on with math in the real world that can relate to percents that we use here as well. But I did want to make sure that we are aware that if you base your percent on 100 and find the other percent, you can find the old or the new number. But if you think, I'm just going to find the change, it's going to be wrong if you only know the number that just showed up. There's a lot of work in percents on the homework, so you can find out more details in there specifically fit our homeworks. Great.